Good morning, everyone. We are going to continue with the unit number 5, that is Web of Things and Cloud of Things. In the last session, we have discussed about the WOT, then what is WOT and the difference between WOT and IoT. Then we have seen some applications regarding WOT. Then the two pillars of web consist of the first pillar consists of HTML, HTTP, and URL, and the second pillar consists of web browser, multi-tiered software architecture, application servers. Then we have seen the platform middlewares of IoT. In that we have seen the three middlewares, that is M2M, SCADA, and WSN. Okay, now we are going to see the platform middleware for of IoT, that is platform middleware of WOT, that is now we are going to see the RFID. Okay, so we have discussed that RFID in the unit number 3, that is what is RFID, how what RFID provides. You know that it provides a unique identification. It provides unique identification technique for the things. Things means devices that can be recognized using RFID reader. You know that RFID reader is used to read that RFID tags. Okay, so that provides a unique identification technique for the things which can be recognized using RFID reader. Okay, so the RFID is the most complete and standardized approach in all of the four pillars of the IoT. We have seen the four pillars including RFID, M2M, SCADA, and WSN. Okay, these are the four pillars of IoT. In that, it is the most complete and standardized approach of among all of these four pillars. Okay, so as we have discussed in the unit number 3, that is EPC, EPC Global, that describes the standards for RFID implementation. Here you can see the EPC Global is working for the RFID standardization. Okay, so the RFID middleware specifies the business logic that is used to filter the data. Okay, that business logic is used to filter the data and extract the useful information from that big data. Okay, or the huge data is there. Okay, so this RFID middleware is used for the to extract the useful information from this data. Okay, so there are some key points are there. Okay, the RFID middlewares, that is it manages the devices, collect and integrate the data, structure and filter data, and tag ID association. Okay, so we'll see one by one, that is manage devices. So in this layer the middleware have to manage the devices with RFID tags. Okay, and that RFID reader are used to detect that RFID tags. Okay, so in this layer the middleware can check the performance of RFID reader and detect some ways to improve that reading. Okay, so in this managed devices, RFID reader is going to read the RFID tags. Okay, then collect and integrate data. So you know that all the RFID tags are read by the RFID reader. Okay, so it is directly processed by the middleware. So that collecting of RFID data and arranging it as per the need is the task of that middleware. Okay, so collecting and integrating the data, that task is of the middleware. Okay, middleware's task is there. Then structure and filter data. So based on the identification techniques, large data about the product. That means this product means on which that RFID tag is embedded. Okay, so this middleware will decide how this data is to be categorized and which data to be used as per the functionalities. Okay, so it also removes the redundancy or duplication of this data or the repeated data. Okay, that is we have to form the structure and we have to filter the data. Okay, then fourth one is tag ID association. So in case of RFID, middleware can allocate and manage the tag ID numbers. We know that every RFID tag or that is these tags are unique. Okay, So where the thousands and more RFID tags are in use, so we have to manage the association of these tags. Okay, so middleware can be used to allocate the tag IDs only to relevant RFID read. Okay, so if we are going to consider the example of RFID middleware, RFID middleware working standards. Okay, that is explained by this cubic association. Okay, this cubic project. Yeah, the cubic project, that cubic is a project in Japan. Okay, so the cubic architecture consists of three layers. So these layers are like for the mobile terminals with RFID tag reader collect RFID tag information and record the locations for the mobile terminals. Okay, with the RFID tag reader. Okay, so the RFID tag information is recorded by the mobile terminals with RFID readers, and it also stores this location. It also stores the location based data. Okay, then the mobile terminals are connected via cubic architecture, which can share data of other RFID devices that are read by other terminals. Okay, that means it shares the data among other terminals. Then this data can be searched to locate the specific RFID tag using this architecture. Okay, so observer can search the RFID tag information to estimate the location of target person. Okay, so this is all about the platform middleware for the WOT, that is RFID. Okay, so now we have covered the four pillars as a platform of for the platform middleware of the WOT. Okay, now next point is unified multi-tier WOT architecture. Here you can see the unified multi-tier WOT architecture. There are three layers are there: your presentation layer, logic layer, and data layer. Okay, so this presentation layer, or based on the middleware perspective, we have studied in the last session as well that the IoT that IoT based application realization can be done with the help of IoT. Okay, so this is the framework that satisfies the middleware requirement of the WOT. Okay, this figure shows the middleware approach for IoT that can be considered for WOT. As WOT, we know that WOT nothing is nothing but a application overview of IoT. Okay, so this is the figure of multi-tier IoT middleware. So multi-tier IoT middleware adds the IoT based connectivity and service oriented layer in the existing three layer architecture. Okay, as shown in this figure, we have seen that the basic three-tier architecture consists of the data layer, then the logic layer, and that your logic layer means this is the middleware. Okay, so and the presentation layer. At presentation layer, UI interface, that is user interface is there. Okay, so first one is your data layer. Okay, so this data layer, so data layer handles all the data generated and storage in WOT. Okay, this data layer handles all the data generated and storage in WOT. Okay, so this layers handles data gathered from distributed sensors and actuators and provides a mechanism to store securely. Okay, so this, yeah, you can see this data layer. Okay, sensors and actuators are there. We are going to gather the data from the distributed sensors. Okay, so this layer also needs operating system. Here you can see this OS is there. Okay, so this layer needs operating system that regulates the flow of data with the other systems or other system activities. Okay, so along with this database, here you can see the real-time database is there. Okay, so along with this database, WOT and IoT system might need the real-time databases based on the application requirements. We need the real-time database based on this requirements of application. Okay, so this data layer is the basic layer of this architecture. Okay, then the second one is your middleware, that is logic layer. Okay, so this logic layer defines middleware. Logic layer defines the middleware and the application logic of the whole IoT and the WOT system. Okay, so this layer regulates the working of the application. Okay, so for the IoT and the WOT, IoT and WOT based systems, the IoT based connectivity and the service oriented architecture is an add-on as compared to usual this three-tier architecture. Okay, so we know that the smart objects and devices are distributed in this field for implementing the IoT application. This logic layer consists of the connectivity, application server, business intelligence, service oriented architecture. Okay, so this is implemented using the IoT based networking techniques like M2M gateways, field bus, WSN, SCADA. Okay, so the service oriented architecture that defines how the data will be represented to different layers. Okay, and the basic middleware techniques like application server utility using Internet Information System, that's IIS. Then .NET framework is also implemented using logical layer. Okay, so this is the second layer of or the middleware for this architecture, and the last layer, that is presentation layer, or we can say the user interface. Okay, so this presentation layer consists of HMI, that is human machine interaction, IoT graphics, data mining, front end. Okay, so this presentation layer defines the user interface of the WOT to the outside world. Okay, that means this is the GUI to the, or it's a front end in short. Okay, so this layer provides a mechanism to access the information and services that are provided by these uh, two layers, that is data layer and the logical layer. Okay, and the IoT based system and WOT has IoT based graphical representation. IoT based graphical representation, and or that representation provides functionality like report generating, data mining. Okay, the HMI tools are there in SCADA. Okay, decision support system is there. So this is all about the unified multi-tier WOT architecture. Okay, then your next point is WOT portals and business intelligence. So the now in this section we are going to see the we are going to discuss about the data access. That data access is done by the users in WOT, and how the business intelligence or that BI is effective in the WOT. Okay, so or link web portal or links, that page is website. Okay, that functions as a point of access to information in the world wide web. That means a web portal provides a point of access to the world wide web using URLs and addresses. Okay, so we can access these portals, or we can access the web portals using the world wide web that uses the URLs and addresses. So this links, web pages and web portal gives combined information from the diverse data source in IoT environment. Okay, web portals are web portals have the portlets, and application in web portals which receives the request and returns the appropriate information. Okay, so that we have discussed this about the web portals in the unit number 3. That is, we have seen the two types of this web portals, like horizontal and vertical. Okay, so horizontal portals covers many areas, while vertical web portal focuses on only functional area. Okay, so we have seen that a Java specification request, that is JSR, the standard was developed in around the 2001, which is re-evolution of the web portals. Okay, so that it allows various web portals to communicate with each other, even the with the cross-platform as well. Okay, so web portals have the portlets and application in web portals that receives the request and return the appropriate information. Okay, see the WOT portals. Okay, here are the examples of the web portals for the IoT or the WOT. Here you can see, yeah, this achieve enables you store, share, and discover the real-time sensors, energy, and the environment's data from building or the other devices. Now it is called as the Vivri.com. Okay, so this platform provides IoT solution as per user requirement, where you can connect various devices and handles them online. Okay, you can handle the devices online. Then next one is a sensor map. Okay, sensor map from the Microsoft. Okay, so sensor map was it was a Microsoft's project. Okay, so here user can publish their live data collected by the sensors or other smart devices. Okay, using sensor map. Then another example like okay, just a minute. Okay, another example like Sunspot, that is your small program object technology. Okay, so it is a WSN developed by the Sun microsystem that provided a way to program the IoT needs using a Java programming languages. Okay, so these are some examples of the web portals for the WTO or IoT. Okay, now next point is the business intelligence. Okay, here you can see the use data. Use data means your big data. Okay, so use data is collected by large number of sensors. Okay, that data is available in the raw format. Okay, we are having the data, that data is collected through the sensors and it is in a raw format. Okay, that is raw data. So to make sense of this data, the WOT middleware defines a business logic in the sense of that is your middleware. Okay, so WT middleware defines a business logic which converts this data into meaningful information. Okay, this middleware or this business logic converts this raw data into a meaningful information. So this kind of logic is known as BI of the WT. Okay, that is your business intelligence. That means we are going to convert this uh, collected data. That data is available in the raw format, and we are going to convert the data into a meaningful information using a business logic. Okay, so data mining. So data mining is a well-known mechanism for this or to implement the business intelligence. Okay, so if you know that the data mining means we are going to discover, or we are going to what we can say, we are going to separate, or we are going to collect the useful, or we are going to extract the knowledge, or we are going to extract the meaningful or useful information from the large data or the big data. Okay, that is your data mining. So it is a uh, data mining is a well-known mechanism to implement the business intelligence. Okay, so like decision support system is another mechanism. Okay, so decision support system is also a mechanism to implement this business intelligence. There are some common uses of business intelligence like data report generation, then data analysis, data mining, benchmarking. Okay, so BI also provides a historic or present and futuristic views to the system by using the available data. That means we are going to analyze that data. Okay, then see the business intelligence, that how we are having the business intelligence tool. So we are based on the past data, we are going to analyze the data. We are going to analyze the data through the business intelligence tools. Okay, and we are going to use this past data using the business intelligence tools. We are going to analyze the data, and based on this analyzed data we are going to improve the future, what we can say, future perspective. Okay, that means we are going to make some changes based on this past data, or if there is any raw data is available in that data, that means we are having the raw data, and through that business intelligence tools, like if we are going to consider the Vika tool for the data mining. Okay, or some decision support system is there. Based on these systems we are going to analyze the data, and we are going to make some changes for the future purpose. Okay, so this is the business intelligence. Okay, here see this, all businesses using IT systems like or to operate, or the manual operations. IT systems or manual operations generate the raw data. Okay, here you can see this. Business operations are there, manuals or IT systems are there that generates raw data. Okay, so we have we are going to transform that raw data into meaningful information, that is business intelligence. Okay, here you can see this, the raw data needs to be analyzed and transformed into meaningful information to achieve the objective of any company. Okay, that means, or this transformation is done by the business intelligence. Remember this. See, we are having the raw data. Okay, and we are going to transform this raw data using the business intelligence into meaningful information, and this meaningful information is again transformed into your, what we can say, your the data is the data is related to the balance sheet. Then we are going to transform this sheet into the your profits statements, like increase revenue, reduce cost. That means we are going to generate the reports based on this transformed data. Okay, so this is the business intelligence that helps us or the company to analyze the past and make actions to get a better future. Okay, that is all about the business intelligence. Now see the objectives of the business intelligence here. Okay, like views, like past, current, predictive. Okay, then the business performance management, that is key performance. Then reporting, on screen and batch reporting. We are going to create the reports. Okay, now here you can see some technical approaches are there. Okay, like benchmarking, data mining, predictive analysis for the this what we can say, this these are the technical approaches for the business intelligence. Okay, that is all about the business intelligence. Everybody understood regarding the business intelligence? Yes. Any doubt regarding the business intelligence? Yes. Anyone? We are going to start the cloud of things. Okay, we have seen, till now we have seen the WOT. What is WOT? WT versus IoT pillars for this. Then we have seen the architecture, unified multi-tier architecture for this WT. Then we have seen the platform middlewares, that is four pillars. Okay, and we have seen the business intelligence. Now we are going to start the cloud of things. If anybody having any doubt, ask me now. Yes, anybody having any doubt? Have you understood everything? Yes, you can unmute yourself. If you are having any doubt, then ask. Tell me yes or no. Have you? Yeah. Are you able to listen? Yes. Am I audible? Gorde Aishwarya. Yes, Gorde Aishwarya, unmute yourself.
Yes, sir.
Am I audible?
Yes.
Yeah, okay. Have you understood the business intelligence?
Yes, sir.
So tell me some uses of business intelligence. We have seen some common uses of business intelligence. Yes, tell me the common uses of business intelligence. We have seen that the common uses of business intelligence. Yeah, data report generation, data analysis, data mining. What is data mining? Data mining. Yes. Manjusha Shinde. What is data mining? All of you unmute yourself.
Data mining is a process of raw, raw data into useful information.
What? Yes, Nirmal Divya. What is business intelligence? What is business intelligence? Divya Nirmal.
Yes, sir.
Yeah, tell me what is business intelligence?
Business intelligence.
Yeah, I already provided you the PPTs and all the notes related material regarding the lab assignments, class assignments, then the PPTs of all the units. Okay, tell me what is the business intelligence? Have you understood everything till now? Yeah, everyone. Have you understood? Then first we have to cover the next point. Yes or no? We are going to start the next point, cloud of things. Yes, have you understood everything? Akshida, Gamdade Akshida.
Yes, sir.
Have you understood?
Yes, sir.
Okay. If anybody having any doubt, you can ask me now or later. Okay. No problem. Okay. So now we are going to move to the next point. That is cloud of things. Okay. So anyone tell me what is cloud? What is cloud? What is cloud computing? Most of you are having the presentation on this, or you have chosen the point as the cloud computing. Okay. So tell me what is cloud and what is cloud computing? What is cloud computing? Yes. What is cloud computing? You can see on the screen what is cloud, what is cloud computing. Most of you from your class have chosen this topic. Yes, Vaishali. Bornare Vaishali.
Yes, sir.
What is cloud? What is cloud computing?
Means on-demand storage available.
Okay. Okay. So the cloud, it is a set of services and technologies that enables the delivery of computing services over the internet in real time, that allowing end users instant access to data and application from almost any devices with internet access. Okay. So just like your IoT, cloud computing also relies on the communication network. Okay, that communication network provides various services. Okay, so cloud computing is derived from grid computing. Okay, that means both the technologies tries to use computing resources from multiple locations. Okay, you can access that resources from multiple locations through the communication network. Okay, so both the approaches, that is your grid and cloud computing, provides a distributed and parallel programming environment. Okay, that is your parallel virtual machine is there, message passing interface is there. Okay, and the job scheduler plays, or these three things plays an important role in building a middleware for grid computing and for the cloud computing. Okay, so the some key features of this cloud computing and the grid computing is like that. This both will provide a single system image. Okay, that means a parallel virtual working stations that hides the essential implementation based on the clustering technologies. Okay, so I think you should know about this clustering. What is clustering? Okay, search for this clustering techniques, go for the cloud or the grid. Okay, grid computing. Okay, so there are several examples are there, like we are having Amazon Web Services that provides a combined user interface using a web services over the internet. Okay, and cloud computing also supports virtualization that creates virtual versions of the resources like servers, storage, operating systems. Okay, then yeah, cloud service has some distinct characteristics that differentiates it from traditional hosting. Okay, it is sold on demand. As okay, that is on demand we can access our data that are stored on the cloud. Okay, it is fully managed by the provider. Okay, the services or that cloud services are there that are managed by the cloud provider. Okay, different cloud providers are there. Okay, okay, that's it for today's session. We will stop here. Uh, in the next session, again we are going to see the cloud of things, grid computing, cloud computing. Okay, clustering. Okay, and the cloud providers. Okay, we are going to start from the cloud computing again. Okay, now we are going to stop here. If anybody having any doubt, you can ask me now. Okay, yes, we are going to stop here. Anybody having any doubt? Yeah, anybody having any doubt regarding this? Till now we are yeah, yes, Shubhangi.
No, sir.
Okay, so we'll stop here. Thank you.